minus R now. Clear? So we have alcohols, say whatever alcohol we have, if we add simply our hydrogen halide. If I am writing HX, it means HCl, HBr or anything. This is known as the Grooves process, in which we are simply adding HX. अब ये देखो यहाँ पे ये positive है, पूरी organic chemistry ही is based on it. You just have to remember the reagent. R plus OH minus है, यहाँ पे H plus है, X minus है. So naturally this OH minus and H can come out as water, and R plus and X minus can form your haloalkane, whatever that is what exactly we want. So Rx plus water. Now we want to get rid of this water naturally, because we are interested in the product which is of interest to us. So this is Rx plus water. So in order to, which acts as a catalyst also, and you know what a catalyst does. It increases the rate of the reaction, that is the kinetics. So we are not going into the kinetics, but understand and appreciate how one branch of chemistry helps the other. Kinetics acts as a catalyst, so it helps, gives you a better yield, and anhydrous plays a role in absorbing the extra side product which is getting formed. So this is the Grooves process. Forward. And catalysis है, जल्दी से product बनेगा तो जल्दी से, and once your water gets absorbed, then it will no longer be available to react, क्योंकि दोनों की availability होनी चाहिए and the reaction conditions have to be favored. Okay, so next you can also have reaction like, you can make your ROH to interact with, first let me talk about PCl3, or it can also react with PCl5. Again, you know, RCl will be formed. So in this case, if I have 3Cl here, I should be taking 3 ROH here, because 3R and 3Cl will form 3RCl. That's general. Plus, you now have O3, H3 and P. So this will form H3PO3. Okay. Remember this equation right here, right now. ROH plus phosphorus trichloride gives you RCl, वही बना रहे हैं, plus H3PO3. For PCl5, you have RCl plus POCl3 plus HCl. Alright, ROH से ही there is another way, that is generally for, this is generally used for preparation of bromo or iodo alkane, where you have Rx plus, side product is not written, and then another method from alkanes can be ROH plus SOCl2. ROH plus SOCl2 will give you RCl plus SO2 plus H2O. This is considered to be the best method of preparation of alkyl halides from alcohols, because the side products are gases. This is water vapor which can be gotten rid of by just simply evaporating it, and sulfur dioxide is also a gas, so it goes out. Sorry, HCl is a gas. The side products are gases. In this case, what you get is RCl, SO2 plus HCl. Okay? So remember all the reactions that I've put on the board, and if there is any extra, I'll just put it for you. Generally, this is known as the thionyl chloride, which is carried out in the presence of pyridine. This is your pyridine. Okay, I repeat it again. We are doing the methods of preparation of alkyl halides. When we add HCl, we get RX plus water. When we add, and this is when we add it to alcohol, all of them to alcohol. So you have ROH, तो आपको पता है OH को निकलना है and Cl has to come in place of OH. So this is one nucleophile. What? And then you know, this also you've done in the last class, what is nucleophile and what is an electrophile? Remember that nucleophile are electron rich and electrophile are electron deficient. Do not get confused, because electrophile se some students get confused thinking that it is electron, but it is electron deficient. I don't want to speak it up, then you may actually get it stored somewhere in your mind. Electrophiles are electron deficient, जिनके पास electrons नहीं होते. Nucleophile are always electron rich. तो negative charge किस species पे होता है? Negative का क्या मतलब होता है? जिसने electrons ले लिए हैं, जिसने ले लिए हैं वो अब क्या हो गया? Electron rich. तो जितने भी negatively charged ions आएंगे organic में, all of them all are nucleophiles. So now here OH minus is going, that means the nucleophile is going, and X minus is coming. So that means it is a nucleophilic substitution, because it is getting substituted, OH minus is getting substituted by X minus. Clear with this? So now a quick recap. HX डालेंगे तो we'll get RX plus HCl plus water. ROH plus PCl3 will give you RCl plus phosphorus acid. Then when you add PCl5, you get RCl plus phosphorus oxychloride plus HCl. Then when you add, for bromine and iodine, it is not a simple method to use the phosphorus tribromide or phosphorus pentabromide. The reason being that they are very heavy in nature. So in order to have the bromoalkane or an iodoalkane, what we do is, to alcohol we add the bromine or iodine in the presence of red phosphorus. ठीक है? तो normally in using this process, we prepare a bromoalkane or iodoalkane. And the best method of preparation from alcohols is that of SOCl2, that is the thionyl chloride method. Why? Because the side products are gases and so they can be easily eliminated. Okay, there's just one method which is mentioned here. You can just write it down if you want. You can have even add to ROH. For bromo and iodo, because we have less methods, for ROH you can add KBr and H2SO4, and for iodo you can have alcohol plus Ki plus H3PO4, and this will give you RBr plus water plus KHSO4, and this will just give you Ri plus KH2PO4. These are the salts which are getting formed, plus water. Okay, so these are the methods. Alcohol is very easily available, so it is considered to be one of the most easily and suitable method for preparation of alkyl halides. Now just remember the reagents once. Alcohol में क्या क्या डालेंगे तो we can get alkyl halides, HCl, PCl5, PCl3, bromine, iodine directly in the presence of red phosphorus, thionyl chloride. What is thionyl chloride? SOCl2. And you can also add KBr in the presence of acid and Ki in the presence of acid. You can remember this much also. KBr in the presence of acid and Ki in the presence of acid can also give you alkyl halide from alcohols. Okay. This is from alcohols. We can talk about the preparation. Please go through the preparations as I am rubbing the board right here, right now. Done? So what we have is, you can also have, मान लो you already have a prepared alkyl halide and you want to prepare another alkyl halide from it. So then that means you need halogen to be exchanged. So such reactions are known as halogen exchange reactions, and those are of the type like you have RBR, like for example you have bromoalkane, you add NaI to it in the presence of acetone, this will give you what? Naturally अब halogen exchange हो रहा है, तो जब बता दिया कि halogen exchange है, so that means Br will get easily replaced by I, so this is Ri plus NaBr. Now such reactions which have a name, for them you have to remember the reagents. Why? Because that scientist had used only that reagent for the successful preparation of that alkyl halide. So this reaction is known as Finkelstein reaction. Finkelstein reaction, alright. Then you have Schwartz reaction also.
Now what is the use of acetone here?
Generally, see, when we actually are using acetone, they provide a solvent media, one is that. And another thing is that it also helps to abstract sometimes, you know, in the solution itself, the side product, which helps in the extraction of the main product separately. That's one of the thing. And in many of the cases, whenever we are adding a particular reagent, it may also be acting as a catalyst. So for Finkelstein reaction, NaI. The moment you remember, you get to read NaI, sodium iodide, what is it going to be? Finkelstein reaction. For the Schwartz reaction, what you have is, you have the chloride in the presence of Hg2F2 to form CH3F plus HgCl2. So in this case, you have the formation of fluoride, alkyl fluoride now, methyl fluoride in the present case that we've talked about. Done? Okay, I repeat it again. Two additional reaction done. One of the preparation method is, what is the one of the preparation methods? From alcohols. The most basic preparation method from alkanes is you add sunlight to it and you add a chlorine in the molecular form, chlorine, bromine in the molecular form. The method which is followed there is the free radical mechanism. You can put it down also. तो free radical mechanism में होता क्या है? What is the problem? Just look, if the very first and simple reaction that I put, it gives you CH4 plus Cl2, that is forming what? That is forming CH3Cl plus HCl. This was in the presence of sunlight or the radiation which is equivalent to that. So CH4 plus Cl2. Now why is this reaction not preferable? Because this proceeds via a free radical mechanism. And you should be knowing that free radicals are very, very reactive. And how are free radicals generated? Just look up here. When you have a normal molecule Cl2, here if the bond gets completely transferred, you know that if this chlorine has completely transferred the bond to this chlorine, it will develop a positive charge and this will develop a, now this will be your electrophile and Cl minus will be nucleophile. But if the bond is not completely shifting and you know a bond is formed by 2 electrons, if it is moving halfway here and halfway on it, then in that case you get the formation of free radicals, and free radicals are very reactive. How the CH3Cl must be getting formed? By the formation of CH3 free radical plus Cl free radical. I am not going into the mechanism, but you can remember that free radical mechanism has 3 steps. Chain initiation, chain propagation, and very good, chain termination. How is it terminated? When you have 2 free radicals combining with one another and they form a molecule. Now here you have CH4 plus Cl2 forming CH3Cl, but the reaction will not stop here. What will happen? This CH3Cl will further interact with more Cl2 to replace hydrogen atoms till they are available. So what will it form now? CH2Cl2. This will form CH2Cl2 plus HCl. And in the next case now, if we have CH2Cl2 plus Cl2, Now you replace it for yourself. Another hydrogen can get replaced. CHCl3 plus HCl. यहीं पे एक फॉर्मूला याद करो, ये जो CHCl3 है, this is chloroform. What is chloroform? CHCl3. What is chloroform again? CHCl3. So chloroform will get formed till it forms carbon tetrachloride. CHCl3 plus chlorine, this will form CCl4 plus HCl. Now the point is it doesn't have any more replaceable hydrogen atoms, so this reaction will not go any further. But what is the point when I'm interested only in getting methyl chloride or chloromethane? Why should I get the rest of the products unnecessarily? Extraction में उतना ही problem हो जाएगा, because अलग अलग करना पड़ेगा. Now coming back to this, I was talking about preparations. Now you keep preparations in your mind. Why am I repeating again and again? Because the reactions are not difficult and you can remember. The simplest reaction was you add chlorine to put on paper. Alkane से बनाने हैं तो उसमें सीधा halogen का वो gas डालो, chlorine, bromine, iodine. Directly you put the molecule as it is and you replace one of the hydrogens. From alcohols, what we have is, from alcohols you have different methods. You can either add HCl, PCl3, PCl5, SOCl2 or KBr, NABr or NaCl, NaI, depending upon what is the requirement in the presence of an acid. Then you can also have, once some of the halogens are already prepared, from them also you can actually prepare the alkyl halide, depending upon what choice you want, by exchanging the halogen. There are two name reactions. NaI बोलते ही क्या याद आएगा? Finkelstein reaction. Mercury fluoride Schwarz reaction. And what else from alkenes? See here, CH2 double bond CH2. This is your alkene. Okay, I add a hydrogen bromide to it. You know that one of the जब भी you have a double bond, it's an unsaturated bond. Saturated क्या होता है? जिसमें सिर्फ single bonds होते हैं, और unsaturated क्या होता है? एक भी double या triple bond होता है. तो when you have a double bond here in this case, how can you actually form a bromide? In this particular case, this can undergo addition reaction. क्योंकि ये डबल बॉन्ड में अब हम क्या करेंगे, इस CH2 के पास हाइड्रोजन, एक के पास हाइड्रोजन चला जाएगा, एक के पास ब्रोमीन. यहाँ पे कोई भी किसी के पास चला जाए, there is no difference because it is a symmetrical alkene. In a symmetrical alkene, remember that the addition will always take place around the double bond region. So even if you have CH3, CH double bond, CH, and this will only undergo addition reaction around the double bond. So you can put down the products yourself. Put it down. This will give you CH3, CH2Br. Alright. CH3, CH2Br. In the presence of, you can have CH3, CH2Br. This is done. Then in this case there is no problem because this will easily give you CH3, CH2Br, and here again what will you get? CH3, CH2, CHBr. The Br could have been here or here. It doesn't really matter because it is a symmetrical alkene. Now when you talk about an unsymmetrical alkene, then you talk about which rule? Markovnikov's rule. Markovnikov's rule. And there, just reminding you, what we have is, if you have an unsymmetrical alkene such as CH3, CH double bond CH2, if you have an unsymmetrical alkene, then the hydrogen will go to that carbon atom which has greater number of hydrogen atoms, and bromine will, or the halogen will go to the other carbon atom. Addition तो इसी तरफ होगी ना, इसके आसपास, because इन्हीं की valency आगे हम we can take it to 4. So the halogen will go to that carbon atom which has lesser number of hydrogen atoms. Basically, where would you like to actually take classes? In a class of 12th standard student or in a class of 11th standard student? 12th, because like is like going towards like. So whenever you add a whenever hydrogen halide is added to an unsymmetrical alkene, then hydrogen goes to that carbon atom which has greater number of hydrogen atoms. और comparison किसका हो रहा है? इन्हीं दो का. इसके साथ तो comparison का मतलब नहीं है, because even if hydrogen goes to this carbon atom, the valency will become 5, which is not possible. कैसे? Because 3 hydrogen already है, एक bond carbon के साथ है, तो hydrogen cannot go there. So that is why you have to lay emphasis of Markovnikov's rule. In the addition process around the double bond, hydrogen will go to that carbon atom which has greater number of hydrogen atoms and halogen goes to that carbon atom which is less. So here in this case, what do you get? CH3, CH, Cl, Br, I and CH3. This is Markovnikov's rule, something that you've already done. But remember, this is giving you what? A secondary alkyl halide. This is giving you a secondary alkyl halide. And sometimes you talk about anti-Markovnikov's rule also. That is when hydrogen bromide is added in the presence of peroxide, like for example benzoyl peroxide. When it is added in the presence of benzoyl peroxide, then the rule becomes reverse, just the opposite of what we've talked about. So then you know hydrogen should ideally go to CH2, but now hydrogen should go to CH. So here you will get CH3, CH2, CH2, Br. This will be a primary alkyl halide. That means a primary alkyl halide can get formed from an unsymmetrical alkene only in the presence of peroxide. And if you want a secondary alkyl halide from alkene, then you undergo normal Markovnikov's rule in the absence of peroxide and you get secondary alkyl halide. Then there is another reaction for preparation of bromide which is known as Hunds-Decker reaction. Hunds-Decker or Hunds-Decker reaction. Reaction. It is from the silver salt of carboxylic acid. Hunds-Decker reaction में, because ये name reactions में reagents are to be remembered. So here you have the silver salt. What is carboxylic acid? RCOOH. Now silver salt of carboxylic acid will be COOH. H is now replaced with Ag. Silver salt of carboxylic acid is made to interact with bromine in the presence of UV radiation. It gives you RBr plus CO2 comes out as it is, CO2 plus AgBr. What is the speciality of this reaction? This will be important for conversions. Why? Now look up, conversions में तो सभी help करेंगे, because आपको पता है कि कैसे alcohol से alkyl halide बनाना है, या एक halo alkane से दूसरा halo alkane बनाना है, या फिर alkane से बनाना है. Here in this case, when you are making it from a carboxylic acid, first of all you take a carboxylic acid, add silver to it. It will actually give you the silver salt. When you add silver salt of carboxylic acid plus bromine, so then in that case it gives you RBr plus CO2 plus AgBr. What is the special feature is that the number of carbon atoms are now one less, because here in this case you have this carbon now going as carbon dioxide, तो इसके अंदर एक कार्बन लेस हो गया है. ठीक है, done with it? Go through it quickly. Remember in Schwartz reaction, the reagent, what was the reagent that I put on the board for Schwartz reaction? Hg2F2, very good. Apart from Hg2F2, you can also add AgF, or you can add, no, or you can add COF2. Yeah, you said COF2. I heard CU, I was COF2, alright. So you can add that for Schwartz reaction. Okay, then let's go to physical properties quickly. Remember, are the preparations done for alkyl halides, all of you all? Take about 2 minutes time to quickly go through all of them. Now from alkenes also and from carboxylic acid also. We've just done 2 extra, that is from alkenes and from carboxylic acids. Now just look up. If we talk about now the trend for the physical properties, what are the physical properties? The ones which can be observed physically without going into the in-depth of the structure. What we have is we can talk about the melting and the boiling point. Now here I did mention to you sometimes back, I did mention to you that when you talk about melting points, you are more or less concerned about the symmetry of the structure or intramolecular arrangements, because you want to know as to how the solid is getting fitted into its crystal lattice. अब तो solid state भी करा है, आपको पता है हर एक solid को melt होने के लिए it will melt, the basic entity will melt and form a liquid. So we want to check out how it fits better into the crystal lattice. Clear with that? And for boiling points, we have to break the bonds, intermolecular bonds, to make it get released in the vapor state. क्योंकि liquid को अब vapor में convert करना है. So therefore we are more interested in intermolecular bonding. Remember both play a role in the because bonding दो type की होती है, एक intermolecular, एक intramolecular. Now we are more or less interested in intramolecular when we talk about melting point, and intermolecular forces play a major role when you talk about boiling point. Is this thing clear? Now just look up. Simple, अभी तो हमने alkyl halide ही करे हैं, aryl पे तो अभी हम पहुंचे ही नहीं हैं. Just you understood this particular point. Melting में हमें उसको crystal lattice से हटाना है. So we want an arrangement which is not very symmetrical, ताकि आराम से वो मेल्ट हो सके. जो ज़्यादा सिमेट्रिकल होगी उसका मेल्टिंग पॉइंट हाई होगा, जो कम सिमेट्रिकल होगी उसका मेल्टिंग पॉइंट लो होगा. इज दिस थिंग क्लियर? एंड व्हेन यू टॉक अबाउट बॉइलिंग पॉइंट्स, you have to lay more emphasis on how it is bonding with other similar types of molecules. Okay. Now when I am talking about alkyl halides, alkyl halides, say if I talk about CH3Br, CH3, CH2Br, and I am talking about CH3, CH2, CH2, and I can keep on elongating the chain. CH2Br. Remember, as the chain is increasing, the polarity for all of them is almost the same, because the polarity is remaining only between the CBr bond. The length of the chain is increasing, which means that greater number of electrons, greater mass and size is increasing. So if size and mass increases, your van der Waals forces of interaction increases. And if van der Waals forces of interaction will increase, then your melting and boiling point will also accordingly increase. Clear with this? Alkyl halides में तो simple है, जितनी लंबी सीधी chain उतना ज़्यादा हमारा van der Waals forces हो जाएंगे, because उतने ही ज़्यादा electrons involved हैं, उतने ज़्यादा interactions involved हैं, size mass increase तो हो ही रहा है, तो it is directly related to size and mass. So was the case in your alkanes and alkynes also. Alkenes, alkanes and alkynes when you did it. So now with branching what happens? With branching, all these melting or boiling point decreases, because now the symmetry gets disturbed and then the surface area is less, and so the van der Waals forces of interactions will be less, and so because of that the melting and boiling points would decrease. Clear? Another important feature here is that we can talk about their we can talk about the solubility also, but before we talk about the solubility, we can also talk about something which is known as the boiling and melting point of different halides. Like if you have RBr, Ri, and then you have RCl. So for which will you think that the boiling point would be the highest? Which has the highest mass? So the van der Waals forces of interactions would be the greatest for that, and so the trend would be like this when you have to talk about. So this is like now common sense. You do not have to mug up each and everything in organic chemistry. Yes, of course, for certain name reactions, yes. Otherwise, it's just a general funda that you have to remember. Okay, now sometimes you also put a question that haloalkanes are very slightly soluble in water. Slightly, despite being polar. Why? This melting and boiling point is like simple for everybody, right? Now when I talk about say the trend of solubility, for the solubility, you know that what do we have? R and X. We know that this bond is polar. We know that this bond is polar, but the polarity remains only between C and X. Now, जितनी लंबी चेन होगी उतना ज़्यादा उसका ऑर्गेनिक पार्ट बढ़ गया. जैसे फॉर एग्जाम्पल, greater the polarity of a particular molecule, greater will be the ease with which it can be soluble. Right? Greater the polarity, greater will be the ease with which it can be soluble. Now here, despite the bond being polar, they are only slightly soluble. Why? Because understand this one funda which applies to the entire chemistry. अगर ये मैंने पहले भी समझाया हुआ है, if you have solute and solvent, you want solute to be dissolved, getting dissolved in the solvent. So then solute already has solute-solute interactions. Your solvent has solvent-solvent interactions. Like if your water is the solvent, then H2O in itself form bonds with other water molecules. So those are the solvent-solvent interactions, and your solute has the solute-solute interactions. Now if you want solute to dissolve in the solvent, it is important that solute-solvent interactions should be greater than solute-solute and solvent-solvent interactions. So here they play a role that the energy which is released, normally that's called the hydration energy. Energy which is released is insufficient to break the bonds between the solute-solute and the solvent-solvent interactions. अगर वो अच्छे से increase, बहुत ज़्यादा energy increase release होगी, तो solute-solute और solvent-solvent interactions के bond टूट जाएंगे and solute will be easily soluble in solvent. So here you will have when you talk about, and why is the solubility less? उसका reason ये है कि जैसे जैसे हमारी alkyl chain बढ़ती जाएगी, the non-polar part increases, so solubility will go down. And as it is, why are haloalkanes less soluble despite the polar bond existing? Because the energy released when solute and solvent interact is lesser, much less, which is insufficient to break the solute-solute and the solvent-solvent interactions. Clear with that? That's like the main thing that we can talk about here. Then we can talk about the the reactions of haloalkanes. Okay, for the reactions of haloalkanes, you know that it can either go a nucleophilic reaction or nucleophilic substitution reaction, or an electrophilic, it can either go a substitution reaction, or there can be elimination reactions also. Let's talk about the reactions now in particular. Chemical reactions of haloalkanes. Now just bear with me, because what you have is, say you know that your bond is polar. This bond, you know now alkyl halide bond is polar, and you are adding a nucleophile to it. So when you add any nucleophile to it, so then in that case what you get is like this X will now get replaced with your nucleophile, and X will be set free depending upon how it wants to go with the nucleophile. So you will have X minus here. This is a simple reaction. अब different reagent से देख लेते हैं क्या क्या substitution होती है, क्योंकि जो भी nucleophile generate होगा वही attach होगा. So just remember this, that if now we add, say if we add OH minus in any form, if we add aqueous KOH, so then what will we get? We'll get an alcohol. Shall I put a reaction? जैसे ये मेरा अगर CH3Cl है, इसमें मैंने अब न्यूक्लियोफाइल कौन सा ऐड करा है? ROH. तो ROH से मेरा क्या जनरेट होगा? या कोई भी aqueous KOH, K plus and OH minus. So in this case, what will be the nucleophile which will be generated? OH minus, and what will I get? CH3OH plus KCl. So alkyl halide से अगर मुझे alcohol बनाना है तो मैं aqueous, please remember the word aqueous KOH. तो aqueous KOH डालेंगे, तो aqueous KOH से याद रखना which nucleophile is getting generated? OH minus. Alright, that means you just have to remember what will get generated. KOH की जगह NaOH होगा तो भी, KOH की जगह NaOH होगा तो aqueous NaOH होगा तो भी हमें alcohol मिलेगा. Alright, now if we add water to it, water will also form an alcohol. ठीक है, जब हम उसके अंदर alkoxide डालेंगे, NaOR, जब हम उसके अंदर एल्कोक्साइड डालेंगे NaOR, हाउ इज दिस एल्कोक्साइड फॉर्म नाउ? लुक इनटू इट, लुक अप. मेरे पास CH3OH है विच इज माई ROH. इसके अंदर मैंने सीधा Na के साथ इसको रिएक्ट कराया, सो आई गॉट CH3ONa. दिस इज नोन एज सोडियम methoxide. This is known as an alkoxide. So sodium methoxide, और generally अगर मैं इस reaction को लिखूंगी plus half H2, and generally if I write this reaction it will be RONA which is NaOR और RONA एक ही बात है. तो basically you have to remember this sodium alkoxide is formed from alcohol. Sodium when added to an alcohol will give you sodium alkoxide. So ROH plus Na will give you RONA plus half H2. So NaOR लिख दो या RONA एक ही बात है. So this will generate OR minus क्योंकि Na plus सोडियम alkoxide, सोडियम तो पॉजिटिव ही है, OR will be minus. तो मेरा Cl अब किससे रिप्लेस होगा? OR minus से. So now this I'll form CH3OR. मतलब अगर ये CH3 होता तो CH3OCH3 बन जाता. That is an ether. तो आगे जाकर when you do, तो this is one of the methods of preparation of ether also from alkyl halides. To alkyl halides you add an alkoxide, you get CH3OCH3, that is ether. और क्या डाला? Alkoxide. Okay. Next you can also add NaI. This is your Finkelstein reaction only. So I am not writing it. When you add NaI, I minus will be formed. When you add NH3, now in NH3 you have NH2 minus the nucleophile which is generated. So you will get RNH2. Here you will get R मतलब हमने CH3 लिया हुआ है तो CH3. This will be RI. This will be ROR. This is RNH2 in the presence of ammonia. सिर्फ ये याद रखना कि कौन सा reagent ऐड करें तो what is getting generated. So NH3 ऐड करने पर it is forming RNH2. And again remember, when I am talking about this reaction of adding of ammonia, look up, you have CH3Cl plus NH3. This is forming RNH2 plus HCl. तो ये हमारा प्राइमरी अमीन बन गया. अगर मैंने CH3 लिया है तो लेट मी जस्ट राइट इट एज CH3 ओनली. तो ये मेरा मिथाइल अमीन बन गया. So this is the fourth class that you do in organic chemistry. So you are doing a preparation of amines from alkyl halides, and which is a reaction now. A property, chemical property of alkyl halides, when it reacts with ammonia, it forms CH3NH2. So that means it is a method of preparation of alkyl amine plus HCl. अब again इसके अंदर I can keep on adding NH3 to it. Again HCl can get eliminated, and sorry, I can have CH3NH2, the primary to the primary itself I can add say RX CH3Cl. This hydrogen is replaceable. So here what will I get? I will get CH3 twice, क्योंकि अब इसका H हटके एक CH3 लग रहा है. So what will you get? CH3 whole twice NH plus HCl. This still has a replaceable hydrogen. So this will be like CH3 whole twice NH plus CH3Cl. This will give you what? This will give you CH3 whole thrice N plus HCl. Still, you know, because nitrogen has a lone pair on top of it, you know, it can form additional coordinate covalent bonds. You remember? So in this case, this CH3 whole thrice N can still react with CH3Cl, accept and extend the bond pair, form a coordinate bond to form CH3 4 times N plus now, because nitrogen will now get a positive charge, and Cl minus. This is the quaternarium salt. Ammonium salt. So मतलब अमोनिया वाली रिएक्शन से प्राइमरी अमीन निकालना इज नॉट अ वेरी गुड मेथड बिकॉज द रिएक्शन कैन गो ऑन एंड ऑन एंड ऑन and which is like you will have several you now but another on the other hand see you get a primary amine, you get a secondary amine, you get a tertiary amine, and then you are getting a quaternary amine also from this method. This reaction is also known as Hofmann's ammonolysis, right? This is also known as Hofmann's ammonolysis reaction. Alright, then let's move on to the next reactions. You can also add, now let's go through the reactions quickly, whatever we've done, the reactions. Look up all of you all. हमने अभी तक alkyl halides की प्रिपरेशन करी है, उसमें वाटर डालोगे तो Cl की जगह OH लगेगा, KOH डालोगे Cl की जगह OH लगेगा, अगर एल्कोक्साइड डालोगे तो OR माइनस लगेगा, तो याद रखना है NaOR या RONA, OR लगेगा, ठीक है. NaI डालेंगे तो वो फिंकलस्टीन रिएक्शन हो गया. अमोनिया डालेंगे तो इट विल बी अ हॉफमैन अमोनोलिसिस रिएक्शन वेयर यू कैन इनिशियली अगर एक मॉलिक्यूल ही गिवन है तो you can write that CH3NH2 will be the main product. Now to this primary amine, if you further add alkyl halide, ये भी तो reaction ही है. Alkyl halide when it reacts with a primary amine, it will form a secondary amine. When a secondary amine reacts with alkyl halide, it forms a tertiary amine. And when a tertiary amine reacts with alkyl halide, it forms a quaternary amine. So इसको separate out भी कर सकते हो. Say supposedly you given a reaction CH3NH2 plus CH3Cl. So remember अब ये Hofmann ammonolysis का second part है. Where from primary you will now get secondary amine, from secondary you will get tertiary and tertiary से quaternary. So it's like a chain. So that's Hofmann's ammonolysis. Done with these 3-4 reactions that we've done? Learned? Good. So here another type of a reaction is, look up on the board. We've already learnt about ambident nucleophiles in coordination which have 2 points of attachment. ठीक है, अब यहाँ पे ध्यान से देखना, अगर if I am talking about CH3Cl, so CH3Cl में if I am adding KCN, तो उस टाइम पे when I add KCN, I get the major product as CH3CN plus of course KCl, ठीक है, but when I add AgCN, then I get CH3NC. And ये वाला question in subjective paper you always get it. Why is KCN giving you a cyanide whereas AgCN gives you an isocyanide? Now the reason is given very beautifully in your books itself that KCN is predominantly ionic in nature. तो अगर ionic in nature है तो this is K plus and Cn minus, and you know that all this is a salt, मतलब kind of K plus and Cn minus. The moment you add KCN in aqueous media it will completely dissociate into Cn और K plus अपना अलग घूमेगा, Cn minus अलग घूमेगा. That is how it is going to happen. Now both carbon and nitrogen are free to form a bond with CH3 का carbon. So because it can either form CC or it can form CN bond. Now because CC bond is stronger than CN bond, that is why the major product is a cyanide here. I repeat, because KCN is ionic in nature. Ionic का मतलब क्या है? The one which is formed by complete transfer of electrons. तो ये K plus and Cn minus हो गया. They will completely are like dissociated in aqueous media. So now because carbon and nitrogen both are free to form a bond with carbon, carbon and nitrogen both are free to form a bond with carbon. So here because CC bond, now it has a choice. Because CC bond is stronger than Cn, it will go in for CC bond formation and cyanide is the major product. Whereas in case of AgCN, this is covalent in nature, and covalent bonds are generally what? Where you have sharing of bonds, sharing of electrons, I'm sorry, to form the bonds. And here, if sharing of electrons is happening, that means your my Cn is not free to move, and N is the only center which is free for attachment. So once N gets attached, it is only then that the rest of the Ag plus is like cleaved. So what you have is CH3NC here plus AgCl. Right? So that way you get isocyanide here. Similarly, for you know that CH3Cl, when it reacts with KNO2 and when it reacts with AgNO2. Now again here, I think here you have CH3NO2 as the main, and here you get CH3ONO as the main. The reason is just the same. Now because CO bond is more stable than CN bond, so that is why isonitro compound is the major product in case of KNO2, and AgNO2 के case में nitro is the major product. That depends on this, where you have the case of ambident nucleophiles. Okay, then AgCN के case में you get R and C, ONO is done. Then you have, alright, when you have CH3Cl plus, you tell me for this quickly. इतना तो मतलब इधर उधर कर सकते हो आप. So you can understand that when you have CH3Cl reacting with COOAg, you get AgCl going out, and this is what is formed. Now this is a method of preparation of alkanes from alkyl halides. Whenever you add a reducing agent to it, like LiAlH4, so what will it form? Simply and this another reaction is an important one. When you have RCl plus R-M, it forms your alkane. This is also a reaction that you've done before for the preparation of alkanes. Yeah, if you have metal as Na, then it becomes with reaction, but then that ways you have simply RCl doubling itself. So those reactions also, I'll just put it down. Just go through these reactions quickly, because with metals altogether you have so many reactions which are there, and we have to do aryl halides also. Do you know the words reaction? Do you want me to put it on the board? Good. What's the reaction? RCl plus 2Na. That gives you what? RCl plus 2Na. That gives you RR plus NaCl in the presence of dry ether. That's your Woods reaction, where you have doubling. Then if you have aryl halide like benzene chloride with another benzene chloride, then that in the presence of that you have in the presence of, if it is in the presence of copper, then it is known as an Ullmann reaction and you get biphenyl. If it is ClCl and that is in the presence of sodium and dry ether, then it is known as the Fittig's reaction. Okay, remember this also, because you get entrance examination, it comes as a direct question. I repeat quickly, although you know CH3Cl plus, if I add Na here in the presence of dry ether, this Na should remind you of Woods reaction. So here you have twice CH3, so you get your alkane, which is double the number of the original number. So whenever you have to increase, step up your product, so then in that case you refer to this, and that will be plus NaCl. Now if I have, instead of this, I have say chloride plus 2Na in the presence of dry ether, then I will actually get biphenyl, and this reaction is known as Fittig's reaction. This is your Woods, this is your Fittig's, and whenever you have say iodo, if you have iodobenzene plus copper in the presence of you have in copper only, and you heat and just provide the activation energy, proper activation energy, then in that case again you get a biphenyl. In this case it is known as an Ullmann reaction. Only the name of the scientist changes, so remember that if sodium is getting replaced with copper, then it's just an Ullmann reaction. Then apart from it, I think now we're just left with elimination reactions. This is done. And remember, when you talk about the reaction with metals, there are several reactions with metals. This is done. This was like one of the ones that you can talk about metals here. And you can talk about Rx plus Mg in the presence of ether again. What will it form? RMgX. This is a very, very important reaction because this is your Grignard reagent, which is very, very, very important for conversions, as you will actually take up in some times from now. When you have say Rx plus Zn, when you have Rx plus Zn, so then in that case what do we get? When we have Rx plus Zn, we get R ZnR. This is dialkyl zinc. Okay, remember that this is another type of reaction with metal, and also this is also important. When it reacts with lithium, it forms RLi plus LiX. See, this reaction is also important because it is not necessary that each time you add a metal, it will either get inserted or double. The doubling happens only in case of Woods reaction where you are adding sodium in the presence of ether. If you are adding magnesium, वो अंदर ही चला जाएगा. और फिर उसके बाद अगर zinc add कर रहे हो तो it will cause doubling but get inserted, so it will be R, Zn, R, and when you are adding lithium, it replaces your X. So depending upon which metal you are using, the product will be according to that only. Okay. So then you've done a number of reactions also. Remember that the reaction of formation of ether that we had done with the help of alkoxide, that is known as Williamson's synthesis. And then when we do ethers, we can probably talk about how Williamson's synthesis can actually be used to prepare different kinds of ethers. You can actually get tertiary or primary depending upon what reagents you are choosing. Okay, then we have after nucleophilic, we can talk about if you have CH3, CH2, CH, Br, CH3, hydrogen and halogen, so it will lead to dehydrohalogenation. Now if it was a simple CH3, CH2, Br, look up here, अगर इसमें मैं alcoholic QH डालती हूँ तो रिमेंबर जिस कार्बन से ब्रोमीन निकलेगा उसके साथ वाले से हाइड्रोजन निकलेगा. So if bromine is getting abstracted from this carbon atom, hydrogen will leave from the adjacent carbon atom to that carbon atom. So you have, if CH3, CH2Br is there, you have talked about elimination and the mechanisms were done in the previous class by sir. So you have CH3, CH2Br, alcoholic OH मतलब HBr अब निकलेगा. So that means minus HBr, H from this carbon and Br from this. So this will form CH2 double bond CH2. It is forming a symmetrical alkene, no discrepancies here. But now here, when we add alcoholic KOH, here in this case, so bromine will leave from this carbon atom, but the hydrogen can leave from either this or this. So let's write both the possibilities. We can have CH3, CH double bond CH, CH3, ठीक है, bromine इससे निकला CH हुआ, यहाँ से H निकला, और अब वैलेंसी बैलेंस करनी पड़ेगी, otherwise it will be 3, so we get a double bond here. So this is one of the alkenes. The other alkene is CH3, CH2, CH double bond CH2, right? Now out of this, this is the major product and this is the minor product. Why? Because greater the symmetry of the alkene, more is the stability. This is according to Saidzev rule. All right. Greater the symmetry about the double bond, greater is the stability, and that alkene will be more favored. So remember, when we talk about alcoholic KOH, this is what we are going to get. Also, another important reaction that you can write is known as the Swern oxidation. Swern oxidation. What is that? RCH2X. The ones who are feeling sleepy can have water. That is RCH2X plus, in this case, you can prepare aldehyde from this. So this again is a special one. You add an oxidizing agent to it. देखो oxidizing agent का मतलब है अब हम इसके ऑक्सीजन ऐड कर रहे हैं. ऑक्सीडाइजिंग एजेंट K2Cr2O7 एंड KMNO4 तो इमीडिएटली दिमाग में आते ही हैं. बट देयर आर अदर ऑक्सीडाइजिंग एजेंट्स ऑल्सो, लाइक यू हैव डाईमिथाइल सल्फॉक्साइड. दिस इज DMSO. DMSO नाम का रिएजेंट जब आप इस रिएक्टेंट में डालते हो, so what you can get is RCHO. Okay, this is a method of preparation of aldehyde from alkyl halide. What is this known as? Swern oxidation. Okay, rest I think more or less we've done a lot of reactions, and don't think because trihaloalkanes and all may be left, but we can talk about now straight away for the aryl halides quickly. Alkyl halides is like, you know what is SN1 and SN2 reaction, and we've done it in the last class, so I'm not taking it up again. You know, it is simply 1 degree अगर alkyl halide है, it will go SN2. अगर 3 डिग्री है तो इट विल गो SN1. ये चीज याद रखना. और 2 डिग्री हैज अ चॉइस डिपेंडिंग अपॉन हाउ इज द effects, I mean how is the alkyl group. It can actually either go SN1 or SN2, but primary है तो SN2 और tertiary है तो SN1. That is substitution nucleophilic unimolecular reaction. And the other one is substitution nucleophilic bimolecular reaction, जिसमें 2 reagents शुरू में involved होते हैं वो SN2 होती है, and जिसमें एक ही involved होता है वो SN1 होती है. ठीक है? Do you want me to show it on the board? Okay. So we can then quickly talk about aryl halides. Quickly go through the alkyl halides in about 1 minute's time. All of you all, the alkyl halides and the reactions. ठीक है? I'll ask you questions from it right now. There have been no doubts today as such, so I expect that all of you all are remembering it side by side, because there may be one class that you may have in your schools also related to it before, because most of you are through with your courses also by now. So, and the more you actually go through and have a glance through them, the more you get a better picture of. So what you are supposed to do while doing the preparations, देखो preparations तो कुछ ही हैं. There are only some 4-5 preparations, go through them quickly. For the reactions of that particular reagent, what you can do is just remember the reagents and the final product. क्योंकि reagent से याद आएगा, जैसे अगर nitrating mixture है, कोई भी nitrating mixture होता है, that is H2SO4 and HNO3. It is a combination of both. Okay, when you talk about sulfonating agent, it is, we'll just do it. Let's talk about first, like for example, if I now talk about the preparation of alkyl halide. Toluene is a hydrocarbon. So we have CH3, this is with benzene. You can add X2 in the presence of, this will give you what? This will give you ortho and meta. You can have ortho means you can get an X attached at ortho position or at meta position. This is also a haloarine. This is ortho halo. This is ortho halotoluene. This is para halotoluene. ठीक है? अब अगर मुझे directly haloalkane चाहिए, तो उस case में what I can do is, if I want directly, then I can actually prepare, the best method of preparation is from aniline. एनिलीन क्या होता है? व्हेन यू हैव NH2 ऑन बेंजीन. ठीक है, कैसे? इसके अंदर द बेस्ट रिएक्शन इज द डाइजोटाइजेशन रिएक्शन वेयर यू ऐड NaNO2 प्लस HCl in the presence of 0 to 5 degree Celsius, or that is 273 to 278 Kelvin. 0 to 5 degree Celsius. So this will give us what? This will give us N2Cl. This is benzene disonium chloride. So this is the diazotization reaction, and then you know that this acts as a hub from where you add different reagents to it, and you can get different products. Like for example, if you add now Cu2X2 to it, and then you simply get, what is this reaction called? N2 will be eliminated. This is known as the Sandmeyer's reaction. If to N2X, simply you add your Ki, then in that case you get iodobenzene. And then you can have a different set. If you add water to it, you get an alcohol. But because we are doing the preparation of alkyl halides, not going into that, but this is Cu in the presence of H6 also. Okay, so this is your benzene disonium chloride. I hope all of you all remember the diazotization reaction, that you have chlorobenzene and that you have aniline, and to aniline you are adding NaNO2 plus HCl in the presence of, what is the temperature condition? 0 to 5. It is very important to maintain that condition. So that's ice cold conditions which are maintained in the lab. So then you get benzene disonium chloride. This diazo product is also used to form dyes. So N2Cl में CuX2 डालेंगे in the presence of HX, Cu2Cl2 in the presence of HCl will give you chlorobenzene, and similarly your bromobenzene. When you add Ki, you get iodobenzene. When you add अब इसका यहीं पे कर ही लेते हैं, CuCN in the presence of HCN, so then in that case you will get what? You tell me? Cyanobenzene. If you add HF in the presence of BF3 and heat it, this is the Sheeman reaction, Ball's-Sheeman reaction, and you get fluorobenzene in this case. And there is a Gattermann reaction. Gattermann reaction में you simply add, instead of Cu2Cl2, copper powder along with your HX. So you get your X here. So this is your Sandmeyer reaction. This is your Gattermann reaction. This is your Sheeman reaction. And you can get cyanobenzene. You can get an alcohol also here when you add water or aqueous KOH. ठीक है? So from alkyl halides you can get a wide range of products from here, which is very important. And remember, of course, the most basic reaction is also possible, that you have benzene, and to benzene you straight away add chlorine in the presence of light. So that will give you haloarine. Okay, I'll keep my hands down. So here we have the reaction. I'm not putting the reaction for the general reaction of preparation of haloalkanes from benzene. Benzene में Cl2 डालो in the presence of FeCl3, that will give you haloarine. Okay, but the most important reaction is the diazotization reaction only. Now for the reactions, before I move on to the reactions, this is one set of preparations which is done. I want all of you all to look up here on the board, up, not on your notes. See, till now we have done only alkyl halides and their properties and the reactions. Here we are laying emphasis on the formation of haloarenes. Now you have to understand that here what is the nature of the group which is attached onto the benzene, to know whether it is orthodirecting or paradirecting. For that, first of all, before talking about that, let's quickly recap the preparations. From aniline we make it to undergo a diazotization to form N2Cl. From N2Cl से different types of reactions करके we get our haloarenes. How? Cu2Cl2 in the presence of HCl, Sandmeyer reaction, मिलेगा तो haloarene. Then you have Cu copper powder in the presence of your HX hydrogen halide. You will get again haloarine. Ki डालेंगे, simple heat करेंगे, you will get iodobenzene. CuCN तो cyanobenzene. KOH तो alcohol. अगर HF in the presence of BF3 or H, you can also add H3BF4, H2BF4. So then in that case again you get fluorobenzene. These are the different reactions for preparations of haloarenes. Now when I am talking about the haloarenes, here you also need to look into this particular thing that you can have, this is haloarenes. Now this is like very basic thing that you need to understand as to why it will undergo ortho or para substitution. You have Cl here, okay, you know this Cl has 6 electrons, around 7 in fact, the 7th one is involved in the bonding with the carbon atom. Now this lone pair can shift to this bond. अगर ये इस बॉन्ड पे शिफ्ट करेगा तो इस बॉन्ड का क्या होगा, ये बन जाएगा डबल बॉन्ड Cl और ये पॉजिटिव चार्ज आ जाएगा. अब अगर ये कार्बन डबल बॉन्ड ले लेगा तो इसकी वैलेंसी 1 2 3 4 एंड 5, क्योंकि डबल बॉन्ड बन गया, वो हो नहीं सकता. सो इट विल शिफ्ट अ डबल बॉन्ड टू द कार्बन एटम. व्हेन इट विल शिफ्ट दैट, तो इस कार्बन, इस क्लोरीन ने दिया इसलिए पॉजिटिव हो गया, इस कार्बन ने वो डबल बॉन्ड अपने पास ले लिया, सो नेगेटिव हो गया. So this will develop a negative charge. We did not touch these two bonds at all. So what we have is they remain as such. So this is one thing that's happening. Why? Because chlorine is now showing a plus R effect. You have studied the mechanisms in the last class, so I did not talk about it. Normally when you talk about RCl, here CH3, CH2, Cl, alkyl halides हमने reactions और अभी सिर्फ उसके मेन वो करे हैं. We haven't talked about the inductive effect at all. Chlorine shows electronegative effect. It will pull the electron density towards itself. This shifting of the electron density towards itself and the tendency of these alkyl groups to donate it is also referred to as inductive effect. So chlorine shows minus I. Why minus I? Because it is electronegative in nature. And CH3Cl में ये इफेक्ट कम होगा. इसमें अब दो मिथाइल देने वाले हो गए तो इसमें ज्यादा होगा, और अगर 3 कार्बन एटम्स होंगे तो और ज्यादा होगा. 3 के बाद वो कम होना शुरू हो जाता है. तो दिस इज व्हाट इज द ट्रेंड ऑफ इंडक्टिव इफेक्ट, एंड दैट इज व्हाई ग्रेटर द इंडक्टिव इफेक्ट, लिसन टू दिस, greater the inductive effect, greater will be the polarity and easier will be the energy with which it can dissociate. क्योंकि जितना ज्यादा बॉन्ड पोलर होगा उतनी आराम से टूटेगा. तो रिएक्टिविटी इस केस में इसकी ज्यादा होगी, फॉलोड बाय दिस, फॉलोड बाय दिस. ठीक है. Similarly, if I talk about the reactivities, now that I have touched upon this topic, CH3, CH2, Cl, I can have CH3, CH, CH2, Cl, CH3, okay, and then I have CH3, C, CH3, CH3, Cl. अब तो आपको प्राइमरी, सेकेंडरी, टर्शरी पता है. ठीक है. ये प्राइमरी है, ये सेकेंडरी है और ये टर्शरी, क्योंकि क्लोरीन जिस अल्फा कार्बन को अटैच्ड है दैट्स अटैच्ड टू एंड इधर क्लोरीन जिसको अटैच्ड है दैट्स अटैच्ड टू 3. नाउ हियर इन दिस केस, नाउ नोट, सबसे ज्यादा इंडक्टिव इफेक्ट किस में डोमिनेंट है? जितने ज्यादा अल्काइल ग्रुप्स होंगे डोनेट करने के लिए उतना ज्यादा इंडक्टिव इफेक्ट होगा, और उतना ज्यादा इंडक्टिव इफेक्ट होगा, दैट मीन्स ग्रेटर द इंडक्टिव इफेक्ट, ग्रेटर विल बी द बॉन्ड पोलैरिटी and greater will be the ease with which it can get cleaved. So here you have 3 methyl groups giving to the carbon atom, तो इस बॉन्ड की पोलैरिटी सबसे ज्यादा होगी. इधर सिर्फ 2 हैं तो इस बॉन्ड की पोलैरिटी उससे कम होगी, और इधर सिर्फ एक ही डायरेक्शन से आ रहा है तो सबसे कम. So the order of reactivity towards any of the nucleophiles, हमने इतनी सारी reactions करी हैं, towards any of the nucleophiles would be 3 degree greater than 2 degree greater than 1 degree. ये चीज याद रहेगी. So that means our halogens are showing a minus I inductive effect in alkyl group, in alkyl chains, alkyl halides. So they are showing a minus I inductive effect, and the inductive effect increases till third carbon atom and then diminishes. Greater the alkyl groups attached to your carbon atom, greater will be the inductive effect, plus or inductive effect from the alkyl groups, greater will be the bond polarity, easier will be the tendency to get cleaved, so reactivity will be higher. ये चीज समझ में आई. इसका एक्चुअली हाइपर कॉन्जुगेशन से भी लिंक्ड है, बट आई विल टेक अप दैट इन द नेक्स्ट क्लास बिकॉज वी वांट टू कंसंट्रेट ऑन haloarenes right now. We've looked into the preparation of haloarenes. Now chlorine shows minus I inductive effect, but इस case में chlorine is shifting the electron density towards the benzene ring. So here it is showing plus R effect, where R is the resonance effect. तो बहुत डिपेंड करता है कि कौन सा ग्रुप प्लस आर शो कर रहा है और कौन सा ग्रुप माइनस आर. माइनस आर की अभी हम बात नहीं कर रहे हैं. सो प्लस आर में क्या हुआ, ये नेगेटिव चार्ज इधर आ गया. नाउ यू नो चार्ज टुवर्ड्स द बॉन्ड. अब इस कार्बन के पास डबल बॉन्ड बनेगा, ठीक है. इस कार्बन के पास अगर डबल बॉन्ड बनेगा तो ये 1 2 3 और इसके पास एक हाइड्रोजन भी है 4 और एक जो डबल बॉन्ड बनेगा 5. तो इट कैन नॉट टेक अप द वैलेंसी ऑफ 5. सो दिस बॉन्ड विल शिफ्ट टुवर्ड्स एन एटम. Diagrams draw करते time whenever you have to answer in subjective papers, remember bond towards the atom and charge, negative charge towards the bond. क्योंकि हवा में ऐसे ही कहीं पे भी एरो नहीं बना देना कि अपने आप टीचर सोचता रहेगा जहाँ जाए and you mug up the expressions and the diagrams. So be very particular. You should know that this bond is now shifting towards this कार्बन एटम. इस कार्बन एटम ने लिया इसलिए ये नेगेटिव हो गया. अब लेट्स ड्रॉ द नेक्स्ट स्ट्रक्चर. Cl हमारा पॉजिटिव है, ठीक है, क्योंकि उसको हमने छेड़ा ही नहीं है, तो उसको हमने छेड़ा ही नहीं है. सो हियर व्हाट वी हैव इज वी हैवंट नाउ टच दिस बॉन्ड आल्सो. दिस नेगेटिव चार्ज हैज मूव्ड टुवर्ड्स द बॉन्ड टू फॉर्म दिस. तो इसने दिया, पहले नेगेटिव था तो माइनस प्लस न्यूट्रल हो गया. इस कार्बन ने इधर से बॉन्ड बनाया, इधर से शिफ्ट कर दिया तो वो भी न्यूट्रल हो गया. और इस कार्बन ने सिर्फ लिया तो यू विल हैव अ नेगेटिव चार्ज हियर. नाउ दिस नेगेटिव चार्ज विल मूव टुवर्ड्स द बॉन्ड एंड द बॉन्ड विल शिफ्ट टुवर्ड्स द एटम, कार्बन एटम. सो द नेक्स्ट picture that you will have is the next picture that you will have is you have your benzene here, Cl. We did not touch it at all. We did not touch this bond, right? Negative charge is now forming a double bond here. तो इस कार्बन एटम ने जो नेगेटिव था दे दिया तो पॉजिटिव हो गया, न्यूट्रल हो गया. This carbon atom has taken up a bond from one side and has shifted the bond from the other side. So this again will be neutral, this one, and this carbon atom is finally taken. So this will be negative. Now charge towards the bond and bond towards the atom. So what we get here is that you have your Cl वापस. Cl has now become negative, so that becomes neutral. ये दोनों bonds हमने touch नहीं करे, वो negative वाले ने यहाँ double bond बनाया. And we have seen that there is alternation of bonds now. Bonds पहले इधर 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 थे, अब वो. So there is like the resonance effect, and the chlorine has donated the electron density towards the benzene ring. This is known as plus R effect. So chlorine is showing plus R effect. Generally जितने भी हमारे groups plus R effect show करते हैं, उन सबके cases में note that you are getting a negative charge at ortho position and only para position. Again here it's ortho, that's it. So that means अगर मेरा कोई electrophile is like any species which is positively charged, which is electron deficient. तो कोई भी अगर इलेक्ट्रोफाइल आएगा वो कौन सी जगह पे जाएगा जहाँ पे इलेक्ट्रॉन डेंसिटी ज्यादा है. और इलेक्ट्रॉन डेंसिटी कहाँ ज्यादा है, जहाँ पे माइनस चार्ज है, because minus charge means that it has taken up the electron density. So that means my incoming electrophile will only attack either at the ortho position or at the para position. That is why your haloarenes are ortho para directing in nature. जब भी हम बोलते हैं ortho para directing, that means they are ortho para directing for electrophiles. और अगर कोई by chance nucleophile generate हो गया तो वो कहाँ जाएगा, मेटा पे. अगर न्यूक्लियोफाइल जनरेट हुआ तो जनरली हमारे सारे रिएजेंट्स जो हैं unse what we do, we generate electrophiles. I'll just give you an example of that. Did you understand this? So let me just talk about some of the methods quickly, if you've understood this, because this will continue for the rest. For even alcohols, that's the next topic that we'll take up probably. In alcohols, OH is again, and it will show plus R effect. तो हमारा phenol भी क्या show करेगा? It will be ortho and para directing. The reason comes from here that the incoming now electrophile. So that is why haloarenes की जो अब हम reactions करेंगे, they will be electrophilic substitutions. They will be what? Electrophilic substitution. क्योंकि हाइड्रोजन निकलेगा तो हमारा इलेक्ट्रोफाइल ऑर्थो या पैरा पे आएगा. जैसे फॉर एग्जाम्पल यू हैव योर Cl and if we add fuming sulfuric acid will make SO3H get attached. ठीक है, what is the reagent? Electrophile generated SO3H, that is the electrophile. तो हमें कुछ नहीं करना, उसके बाद तो सिंपली Cl लो, SO3H यहाँ ऑर्थो पे लगाओ और एक SO3H लगाओ पैरा पे. ठीक है, सिर्फ ये पता होना चाहिए कि क्या कौन सा इलेक्ट्रोफाइल जनरेट हो रहा है, देन योर वर्क इज डन. सो इफ वी आर एडिंग नाउ HNO3 and H2SO4. नाउ अगेन पता कैसे जनरेट होता है, व्हाट इज दिस? दिस इज H2SO4 will give H plus HSO4 minus. ठीक है, HONO2 ये हमारा नाइट्रिक एसिड है बेसिकली. तो हमारा जो H प्लस है ना, वो H प्लस हम H2SO4 से जनरेट कराते हैं, वो OH लेके क्या निकालेगा बाहर? वाटर. सो OH माइनस बाहर निकल गया, OH माइनस यहाँ से निकला तो NO2 क्या बना? OH माइनस अगर निकला है तो अगर माइनस निकल गया है तो बचेगा क्या? प्लस. सो दिस OH माइनस goes out and reacts with H plus to form water, and then this is how I'm just telling you how electrophiles are generated. तो अगर HNO3 और H2SO4 is your nitrating mixture, so now you will add at ortho position and para position your NO2. Okay. Then if you simply add Cl2 in the presence of FeCl3, then you get dihalo ClCl plus you will have Cl at para position. Again here do I have to write down now? This will be orthonitrochlorobenzene plus para-nitrochlorobenzene. ऐसे different reagents, you just have to remember your reagents and then keep on attaching the electrophile at the ortho and para position. Okay, another reaction is that you can actually prepare from Cl, you can prepare alcohol by adding NaOH at 323 Kelvin. This is known as the Dow's process. Dow's. This is known as the Dow's process. So here in this case you have OH getting formed. And let me just tell you here at this point that when you make this react with concentrated HNO3 and concentrated H2SO4. So then in that case it forms OH, NO2, 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 or the ortho and para get substituted, and this is known as picric acid, because this conversion is asked many a times. It's like one of the favorite questions. Because the reaction was not here, I was forgetting the temperature. So it is OH, and this is your 246, 24, hello, yes, 1, 2, 3, 4, 5, 6, 246 trinitrophenol. This is how it is prepared. And let me just tell you, if you have the Dow's process become easier if you have nitrate nitro group already present with your chlorine. So we can talk about it again later. So what I wanted to tell you more was, say if I talk about the physical properties, if I talk about the physical properties now for our dye substituted haloarenes, for our dye substituted haloarenes, तो इस केस में ये possibility है, you can have this also a possibility and you can have this also a possibility. Alright, so now just look, earlier for alkyl halides generally the melting and the boiling point trends were just the same. Now here when I talk about these trends, here just look, when I talk about the melting point trends and the boiling point trend, let me tell you which will be the highest. I'll just put, you have to tell me which will have the highest boiling point and which will have the highest melting point. The highest melting point will be that of para. Without wasting time, para will be having the highest melting point because it is the most symmetrical dihaloarene, that is 1,4-dichlorobenzene. It is the most symmetrical, so it fits very nicely into the crystal lattice. So it is very difficult and you need a higher temperature to melt it from its crystal lattice and to break. Whereas in case of boiling point, the boiling point of ortho is the highest. Why? Because now you are looking into the intermolecular hydrogen bonding. Intermolecular forces. What kind of intermolecular forces? Say you have Cl here and Cl here. There is another molecule now on top of it. Say, yes, inter you are. एक molecule, दूसरा molecule. So you have hydrogen here, hydrogen here. So they can easily get involved with hydrogen bonding better in this case than your para. We are now, when you are talking about boiling point, when you are talking about the boiling point trend, what are you looking at? The intermolecular forces. Now the intermolecular forces means in this case the interaction of maybe some hydrogen with chlorine. Orientation तो molecule की same ही रहेगी throughout. Orientation थोड़ी change होगी अपने हिसाब से कि ऐसे टेढ़ा हो जाए. मतलब that depends on how you are taking your molecule also. So in this particular case, the bonding is not that feasible for para. You getting some hint? So when you are talking about the boiling point, you are looking at the intermolecular forces. So the highest boiling point will be that of the ortho substituted one, and the melting point will be the highest for the para one, because we are now looking into the fitting into the crystal lattice wala point. Okay, so then after that we can talk about more reactions and reactions. Chloroform and carbon tetrachloride, and you have DDT, dichloro, diphenyl, trichloroethane. All these are also substituted. You have alkane substituted by halogens. You have hydrogen substituted by halogens in the alkane form. So all those chemistries are also important with small ones. I think I will pass on the notes for them to you, because now you've understood more or less how the reactions are to be carried out and some of the basic reactions are to be remembered. Now let's quickly do whatever we've done today, because if you do this, then we'll carry some bit of it in the next class and then move on with alcohols. Go through it. Alkyl halides we started up with. Alkyl halides, you know, are simply prepared from either alcohols. Alcohols से different methods हैं. Either you add HCl, PCl3, PCl5, SOCl2, or you can add red phosphorus in the presence of CX2 or Br2. That is from alcohols. From simple alkane also you can prepare it. You can prepare it from alkenes also. In case of unsymmetrical alkenes, which rule will be followed? In the presence of peroxide, anti-Markovnikov's rule. Alright, so when we talk about, this is like done from alcohols. You can also have a halogen exchange. Tell me the reagent which will be used for Finkelstein reaction, NAI. And what will be formed? Iodoalkane. Alright, if you use Swartz reaction or AGF, AgF, COF2. Alright, you can use either of these reagents. This is the Schwartz reaction where you're talking about halogen exchange. What will happen if you add sodium to your alloalkane? It will get doubled in the presence of dry ether. Name of the reaction. What will happen if you add Mg to RCl? What is the formula? RMgl. What will happen if you add alkoxide to alkyl halide? What will get formed? OR. So what will get formed? Ether. Okay. What is this reaction called? Williamson synthesis. What is Schwann's oxidation? So with this thought process, I think I'll end today's class. Just go through the notes. It will take only about 10 minutes time and study as much as possible because now there is no time to waste. All the best. Thank you.